Now the next step for us is going to be for us to add a couple of secondary rays on top of this main ray. And the way we're going to be doing that is mostly just focusing on this area for shot 01. So let's see how we can first isolate just a piece of the ray around this area. One way we can do that is by, let's do that here at this level. We really don't need, this is going to be the output of the main ray, but we can do this from this point on. Okay, let me just get some room here. And at this level we already have a mesh with thickness, but even though we transform this from a line to a mesh, we still have the parameters that we had before, including the curve U. So we can use a point VOP. Let's create a point VOP. We can use a point VOP. Let's dive inside, and we'll do the same thing, just load the curve view using a bind. And we're going to feed this attribute to ramp parameter. And this time we're going to use color. Okay, I'm going to say color ramp, and let's connect this to the color attribute. Let's go up, and now we can control the color based on this ramp. Let's get some room here. Let's have a look at this. As you can see, 0 to 1, but now let's say that we have 0 here. This is going to be white, and then we'll have black again. So this way we can quickly establish which area do we really want to use to generate those secondary smaller rays, something like this. By defining the color like this, we can then use the color as a criteria, as a condition for us to delete whatever we don't want. Let's create a blast, and on the blast we'll use the expression that's going to say if my color channel X, so this will be the red channel, is smaller than 0.1, then please delete. Sometimes it doesn't recognize the group type that you want to apply this to, so here on the guess from group you should switch to points. That way it knows this expression is supposed to be applied to the points. And as you can see, we got rid of a bunch of geometry. Right now we only have that piece of ray there. It's looking good. And that's the piece of ray that we're going to be using for scattering those secondary rays. Now the next step is going to be for us to scatter some points on this surface. We're going to use a scatter to scatter points on the surface, and you see we get a lot of points, too many. The total count, we're going to be kind of randomizing the number of points, the number of secondary rays that we're going to be getting. And the way we're going to do that is by making use of a very useful expression, fit 01. This expression is basically going to grab a value that goes from 0 to 1 and fit that range from 0 to 1 to whatever you establish as a minimum and a maximum. So we're going to use a random value based on the frame, so it's going to change on every frame. This is a way for you to, an alternative way for you to refer to the frame global variable inside Houdini. And we're going to say it's going to go between 0 and 6. Close parentheses. And then you can see that the total count is going to vary from frame to frame. So it's going to be changing. The total count is going to be changing, and we also want the global C to be changing, so you can just use same thing at frame, and that way it's also two things that are always changing. The next thing we want to do is we're going to use these points to copy splines into this, and then we're going to apply the same type of distortion to each one of those splines. But we know, as we've seen before, if we want to copy something to points, those points need to have at least a normal. ideally a normal and an up vector, but in this case a normal will do because we're not really worried about the orientation of the up vector for the spline. It's going to be so distorted that it's going to be completely impossible for us to actually distinguish what's top. As long as it's kind of facing outward from the surface of the main ray, that's fine. So for that we need normals, and if you turn them on, you'll see we don't have any. So let's create some before we scatter. So before we scatter, when we still have the mesh. So these are the normals from the vertices, they're not from the points. So we place a normal here, say we want to apply normals to the points, and that way the points will have normals, and when we scatter, these points will also have normals. Okay. We know that the z-axis of whatever we want to scatter is going to be aligned to this axis. Now let's create our lines. Let's create a line. This line should be facing towards the z-axis in order for it to be aligned to the normals that we have on the points. So the direction should be 0, 0, 1. Let's make it fairly small, 0.25. And let's see if this is working. Copy to points. So this is what we want to copy, and these are the points. Copy to points, and it's working. Let me just disable the normals. As you can see, it's working. We don't really need any of this as usual. Okay, so now we have these lines being scattered. It would be nice for us to have kind of a gradient on each one of these splines, so that we can also, so we should have a curve view attribute on these as well, because as for the main ray, where we didn't want to displace the tips, the extremities of the main spline, here again it's the same thing. We don't want to offset this point. Everything else can go crazy, be completely distorted, but the first point needs to be kept intact. So it's good for us to have a curve view attribute. I'm just going to select the curve, and what you can do, I'm just going to type F so we can zoom on it. As you can see, it's facing the z-axis, which is great. Right now we only have these 2 points. That's not a problem. As long as we have a curve view attribute, that's fine. So we can just do a resample. If you apply resample here, then we can just turn this on, curve view attribute. Let's leave it at this. This is totally fine. But at least now we have a curve view attribute. And that's something that's going to be carried as well. Let me go to the camera again. Another thing that we can do to kind of make this a bit more interesting is kind of randomizing the size of each one of these lines. And the way we can do that is we can actually apply, create that a random attribute onto the points themselves. And you can use an attribute randomize, which is something that we haven't used so far. And it's also very useful. It's a quick way for you to add some random values to whatever parameter that you want. So on this case, the attribute that's going to control the scale of the objects when you copy something to the points is going to be the p scale. It's a value that it's an attribute that controls the uniform scale on whatever is being copied to the points, p scale. Now here, the p scale is just a float value, and I'm going to put this dimension to 1. The minimum value can be 0.5 and the maximum value can be 1.5, something like that. And that way we'll have different sizes. Let me hide the points. Different sizes on the different sizes of splines, and that's going to be also an interesting thing to have. If we combine these two together now, so this is the output of the main ray. If we now apply a merge to this, let's say combining this with this output, we should see that now we have the starting point of some secondary rays that are going to be being generated by the main ray. Okay. On the next lesson, we're going to transform these lines into actual small, tiny rays.